Okay, so for this problem, what we want to do is we want to find where the graph of 2x squared plus x minus 4, we want to find where this graph is equal to or greater than the x-axis. That's the whole goal here. Okay? So from this point and up. And in order to do that, what we need to know is where this guy crosses the x-axis. And on this one, we don't know if it can factor or not, so let's go ahead and set up the quadratic formula. So I get the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. And the reason I want to know where the x-intercepts are is because if I can find the x-intercepts, I will know where my graph is above the x-axis. Okay, so that's the whole reason. I don't even really need the vertex on this guy. We'll find it in a minute, but it's not one of the big things that I need. So go ahead and simplify this guy out. You might need your calculator. We're going to, if we get a decimal under the radical, we'll need to know exactly where that is. So 1 plus 16 over 4. So let's see, 4 times 2 is 8 times 4. Ooh, that's 32. So 1 plus 32. So the two things we're looking at would be -1 plus the square root of 32 over 4 and -1 minus the square root of 32 over 4. We need to know both of these guys. So what's going to end up happening is you're going to end up with decimal answers down here. And one of the decimals is going to be 1.19. And you can punch this into your calculator. The other decimal is going to be -1.69. And so what we want to do is we want to plot those points. So 1.19 about right here, and -1.69 about right here. And right exactly halfway in between those guys is the x-coordinate for your vertex. Well, we're a little bit concerned about that, but not 100% concerned about that. So let's come back over here and look at the opposite of b divided by 2a. We'll get the coordinate, the x-coordinate for our vertex. So that would be -1 over 2 times 2, which is going to be 1/4, -1/4. That's the x-coordinate for your vertex. And to get the y-coordinate that matches, you take the 1/4 and you plug it into x over here. So what you're going to end up with is 2 times 1/4 squared plus 1/4 minus 4. And what you'll need to do is punch that into your calculator, and when you do that, you'll get your y-coordinate that matches. And then we've got the 3 points on our calculator that we can use to graph. So when you do that, you get negative, I got -3.6. Not sure that that's right. Let me double check that. So 2 times 0.25 squared plus 0.25 minus 4. I get -3.6. So that guy's going to be -3.6 and 1/4, about right here. And we've got a parabola. Now, the thing that we want to do is we want to know where our graph is above the x-axis. And from this point to the left and from this point to the right, the graph is above the x-axis, and that is where the solution is. So how do we say the solution for this? We'd say that the solution for this is going to be where x is less than or equal to negatives 1.69, or where x is greater than or equal to 1.19. And so that's all that you're looking for on that guy. Okay, I'm double checking my math on that, on this guy right here, and it should be negative 1/4. And so when you get that negative 1/4 in here, this actually is going to give us negative 4.125. All that changes is where the graph comes down to. It still is going to go through the x-axis on those 2 points. So it's still going to have your parabola shape like this. So that'd be the only change from where I got to originally. But it's still you're interested in what's going on from negative 1.69 and from 1.19. Okay, when you're solving this guy algebraically, the first thing that we want to do is turn it into a quadratic formula. And we're going to keep in mind we want this greater than sign, but we would rather have an equal sign here. And we're going to go ahead and move the 15 over from the right to the left. So what this is going to give me is x squared minus 2x minus 15. That looks like 19, so let's... And then equals, and then 0. Okay? Now, solve this out however you want, and you can use quadratic formula. You can factor it. You can complete the square. You can take square roots. So you've got all these options. The easiest, the ones that I would consider first would be this guy or this guy, because I think this will factor without a big problem. And so looking at it, I'm trying to think of the things that multiply to make 15, 3 and 5, 1 and 15, that subtract and make 2. And guess what? It's going to be this guy right here. So x and x minus 5 plus 3 equals 0. And so what we get are zeros at 5 and negative 3. And these are what are called critical points. These are called critical points, and they're really important later in your math life. But today we're just going to use them to figure out where this equation is going to be greater than 15. So now what we do is you draw a number line. So we're just gonna make a number line, and on the number line we're going to put our critical points. So we're going to have a critical point at negative 3 and a critical point at 5. And then what we want to do is we want to test these critical points on our original equation, x squared minus 2x greater than 15. We want to test these guys on this equation. And so choose a value from each piece. So we're going to choose, like, say, negative 4. That's from smaller than negative 3. We'll choose 0 because that's between negative 3 and 5. And let's choose 6 because that's larger than 5. And we're just going to take, and this is going to be, we're going to take these and substitute these in for x. So x is going to equal all these 3 pieces. What does that give us? Well, that gives us negative 4 squared minus 2 times negative 4. And we want to know, is that greater than 15? Yes or no? That's all we're concerned with. And when we do our math here, we're going to get 16 plus 8. And it is 16 plus 8 greater than 15? And the answer is, um, you know, yes, it is. It works. Okay, so this is a true statement. So this part then we would include in our graph. And keep in mind now, we're just greater than or equal to, so we're going to have an open circle at 3. Then check 0. 0 squared minus 2 times 0, is that greater than or equal to 15? Well, you get 0 is greater than or equal to 15. Is that true? And the answer is no. No, it's not. So we don't worry then about the middle. We can't graph the middle. Then check 6. So 6 squared minus 2 times 6, is that greater than 15? So 36 minus 12, is that greater than 15? And the answer is yes, it is. So again, an open hole because of our sign here. And then we would select all the numbers this way. So this then is how you would solve a quadratic inequality by just using algebra. So it's a little bit different, but hang in there. This is something you can do.